Hello students. Now let's try to learn about what are B trees. So before that we have learned about AVL trees. Now how it is beneficial, what are the advantages we have in AVL trees. Prior to that we learned binary search tree as well. So it's like we are trying to keep on improving the tree itself. Okay, so we are trying to make it more convenient for searching purposes. Okay, searching an element can become more efficient. So in a binary search tree we had this problem of skewedness, right? For example, here this is a left side skewed, it can also be in the right hand side as well. So in order to prevent such kind of a tree structure, we have learned AVL trees. Okay, so in AVL tree we try to balance the tree so that the balance factors are within these values of -1, 0 and +1. What happens is the tree is made in such a way that we have less skewedness in the tree itself, and we can reach a particular element which is searched for in a faster way. Alright, now we move to another tree which is called B trees. In B trees we have little bit of changes. First of all, the most important characteristic of B tree is that all the leaf nodes will be in the same level. So what do you mean by level? This may be level 0, then 1, then 2 and so on, right? I hope you know what level of a tree is. So in case of a B tree, all the leaf nodes will be in the same level. Okay, so let's move forward. So this is just the slide where we start with B trees. So before that we had BST, right? Binary search tree. So in case of binary search tree, maximum 1 key per node was possible. So if you look at any binary search tree, suppose let us look at this particular binary search tree, because since it's an AVL tree, of course it's a binary search tree. Okay, so here you can see that all the leaf nodes are not in the same. Okay, even before that the point was to know maximum 1 key per node. So if you look at a particular node, you will see that how many keys are possible here? Only 1 key possible. Okay, just imagine these circles to be one single node. So how many values are put inside? There are only single values. For example, in this case we have 10, here we have 5, here we have 20, here we have 15, and here we have 25, and so on, right? So we try to store more than 1 key in a B tree. Okay, up to AVL tree we could keep only 1 key or 1 value, but from B trees we will be able to store more than 1 value. Okay, so as the definition, not a definition but a small difference says that in case of BST, maximum 1 key per node. In case of B trees, number of keys depend on the order of that particular tree. Okay, so a concept of order will come now, which will be a positive number. Okay, so based on the order value we can keep that many number of keys, or maybe there is a condition that has to be satisfied to keep the certain number of keys. Okay, so we are going to learn that, but here the straightforward information that we get is in case of BST we have a maximum 1 keys. In B trees we can have more than 1 keys, okay, depending upon the order. So in order to understand more about this order, let us take a value, okay, a variable, say m. Okay, so let the order be m. So if the order is m, then certain rules has to be applied on a tree in order to make it a B tree. Okay, so here it says that the root node can have minimum of 1 key and then maximum of m minus 1 keys. Okay, so what is the root node? I think everybody knows the root node. So here it says that okay, we have a tree with us, and definitely if it's not an empty tree we have a root with us. So if we have a root with us, then how many keys can it have? It can have a minimum 1 key and maximum m minus 1 keys. So if the order is 5, then we can have 4 keys as maximum keys. If the order is 7, maximum 6 keys are possible in the root node. Okay, this is all about the root node. Rule 2 says about the non-root node. Okay, so any node which is not a root node is a non-root node, right? Simple. We are going to discuss broadly about that, so don't need to worry. So here it says that it's a non-root node. In case of non-root node, the minimum value will be ceiling of m by 2 minus 1. So what do you mean by ceiling? We have ceiling and floor, right? So if it is 2.5 as a value inside this bracket, then ceiling will be the next integer, right, which will be 3. Okay, in case of floor it would have been 2 but in case of ceiling it will be 3. Okay, so if I have 2.5 here, ceiling will be 3 and floor will be 2. So here we are going to put the value of m and try to find the ceiling of the value -1. That will be the minimum number of keys possible, and the maximum keys will again be same, it will be m-1. So why same? Because in case of root node also it was m-1 keys, in case of non-root node also it will be m-1 keys. Okay, so these are the certain formulas that you have to remember, very simple and straightforward formula. Okay, so don't forget it. Number 3 is all leaves in the same level. Okay, this is what I was talking about. All the leaves in the particular tree has to be in the same level. Okay, so we have to check it every time we reconstruct a B tree. Okay, so we have to see if all the leaves are in the same level or not. Fine. Then number 4 is, if a non-leaf node has n keys, then there must be n plus 1 children. Okay, it says that, okay, if we consider a node, okay, which is not a leaf node, if you consider any node or a non-leaf node, then if it has n keys, then it must have n plus 1 children. Okay, this is also one of the criteria that has to be followed. So whenever we construct a particular B tree, we have to see that this particular rule is satisfied. Okay, why we say non-leaf node? Because if it's a leaf node, of course there will be no children, and that's why it's a leaf node. Okay, then let us try to create a scenario to understand this B tree concept. Suppose m is equal to 5. Okay, so initially we talked about the order of a B tree, right? Something which was not seen in case of BST. So let the order be m. Okay, in order to understand and to know the formulas. But now let us try to have a real value of this m. So suppose m is equal to 5. Okay, so if we have m equal to 5, we had this particular formulas with us, right? Now we will try to put those 5 formulas here. So for in case of root node, minimum was 1, maximum was m minus 1. In case of non-root node, minimum was ceiling of m by 2 minus 1, and maximum was m minus 1 again, right? So you just try to put the values of m, and you find the values to be, the outputs to be 1, 4, then 2 and 4. Okay, so that means if your B tree has the order 5, then your root nodes can have only minimum 4 to maximum 4 keys, and non-roots nodes can have minimum of 2 and maximum of 4 keys. Okay, so we have to remember that if the order is 5. So I have now written an example here in order to understand and how to apply it in a particular real scenario. Okay, how to apply it. So we have m is equal to 5 here, we have the values here. Now we try to put it in example. Okay, so we have an example here, 42, 25, they all come in the shown order. Okay, so they all start from left to the right. So now please pay attention here. Here the game starts. So we have 42. Okay, 42 comes okay as a node. Okay, key for a node. So 42 first enters, then 25 enters, then 15 enters, and then 30 enters. Okay, we have allowed 4 keys to join to become a particular node. Okay, so why we have allowed 4? Because if you look at this table here, if you consider them to be columns and these are the rows, then you see that for a root node, okay, minimum key is 1 and maximum key possible is 4. Okay, so since this is the starting point of our tree, it must be the root node. Okay, because we don't have any other nodes here, we have to consider this entire chunk of information as a single node. Okay, so in this particular node, how many values do you see here? We have 15, 25, 30 and 42. These are the first 4 values that has been taken in order to construct the root node. Okay, but at the same time you also have to maintain the ascending order. So we have 15, 25, 30 and 42. So if you go from the left side to the right hand side, all the values will be increasing in the increasing order. Okay, so we could have also taken 46, but I don't want to take 46 right now to actually show you what has to be done when the number of keys is more than the given value. So for the root node, the maximum value can be possible can be 4, right? So we have taken the 4 elements, so everything is peaceful up to this point. But as soon as we add 46, okay, suppose we add 46 here, now we have more than the values that we have attained, right? We can have only 4 keys, but we have 5 keys now. So what has to be done is pretty simple. You take the middle element, okay, take the middle element and then put it as a root, and then let the other values be children. So what happens is 30 goes up, so you can see 30 has gone up, and all the left elements are kept in the left hand side, and on the right elements are kept in the right hand side as, say, leaf nodes. Okay, so now earlier it was a one single node. If you look at this line, we had a one single root node with 4 elements or 4 keys, but after the 5th element has come, it has the middle element has gone up and it becomes a single node, and we have another two leaf nodes. One is 15 and 25, the other is 42 and 46. Okay, so now it is fine, because as we know, the root node can have minimum of one element. So now this has become the root node. Okay, yes, it has become the root node now, so the minimum value can be 1, so it is having 1 value, so no problem. Okay, in case of non root nodes, the minimum is 2 and maximum is 4. So minimum value is here, we have 15 and 25. Okay, because these are leaf nodes, right, because they are in the last level, but they are also non-root nodes, because root node is this, so they must be non-root nodes as well, right? So we can take this formula from here, that is non-root nodes, the minimum value can be 2 and maximum value can be 4. So we have minimum value of 2 here and also 2 here, so no problem, everything is peaceful at this point. Okay, so then we keep on adding some elements. So after 46 we add 18, 36, so 18 is added here, 36 is added here, 7 is added here, and where is 44? Okay, 44 is added later. So we have 18 is added here, then 36 is added here, and 7 is added here. Okay, so we have added up to 7 here. So let us see how many elements we have. We have 1 2 3 4 5 6 7 8. So we have 1 2 3 4 5 6 7 8. So that is fine, we have taken up to 7. Now how have we put these values? Because earlier we found this value, and after that 3 new members have come. The new members are 18, 36 and 7. So 18, see, because it must follow the properties of binary search as well. All right, so all the elements in the left hand side of the root should be smaller than the root, and all the elements to the right hand side of the root should be larger than the root. Okay, so here you can see we have 7, 15, 18, 25, all these values are lesser than 30, and 36, 42, 46, all these values are greater than 30. Okay, so that is fine, we are following the earlier convention or earlier rule of a binary search tree, so that is fine. Again, we are also keeping the values in the ascending order, because if you look at only these values, we have elements in the ascending order. We have 7, 15, 18, 25, 36, 42 and 46. So inside a particular node also the keys are in the ascending order. Okay, and that's why when we take the three new elements 18, 36 and 7 from this line, okay, we put it in the respective places. 18 must come here, right? 18 must come between 15 and 25, so 18 has come here. 36 will come here because it is later than 30, so of course it will be in this particular node, and it is also less than 42, so it is going to come at this place. And then we have 7 is lesser than 30, so it is going to be of course in this node, and 7 is lesser than 15 as well, so it will come before 15. Okay, this is how we have constructed this. Please try to see if you can construct or you have totally understood up to this point. Okay, because otherwise things are going to get more crazy as we add new elements. So if you have not got up to this point, then you have to think again. Okay, so always remember, whenever you have to put a new element, you just think, okay, where that particular element is going to fit. Okay, because see, you always have to fill this level first. Okay, you have to fill this level first, that is the last level or the level where the leaf nodes are there. You have to fill them completely, and then only you can go to a higher or rather to a top level. Okay, and then make changes. All right, so whenever a new element comes, you cannot directly put it in a intermediate node. You always have to put it in a leaf node. Okay, that's why we are putting it here. We are not, if we are having 36, we are not trying to put 36 with 30. Okay, because otherwise another rule will be broken, which we are going to again discuss. That is, if we have suppose n keys, then we must have n plus 1 children. okay, because if you look at this particular line, if a non leaf node has n keys, then it must have n plus 1 children. So a lot of things get violated. So right now you just try to remember that initially we had 4 elements, which is the maximum capacity. Once the new element comes with which exceeds the capacity, then we have to move the middle element to the top and make 2 other leaf nodes. Okay, so there will be one root node and the other 2 nodes will be leaf nodes. Okay, then you keep on putting the elements in the leaf nodes, okay, until there is a overflow. Okay, so now as we move on, here you can see we have 4 elements, that is fine, but as we add 44, okay, as we add 44 here, because 44 was not here, so when we add 44 here, this is also fine. Okay, so in this node also we have the maximum capacity, so everything is fine, and in this node also we have the maximum capacity, so everything is fine up to this point. Okay, so now let us try to move forward. We have put up to 44, I think. Yes, we have put up to 44. Yes, then we come to 6. So when we put 6, now where do we put 6? We must put 6 to the left hand side of 30, and it must sit in this particular node. And where will it be placed inside this particular node? Yes, before 7. So when I put this element before 7, we get this value 6, 7, 15, 18 and 25. Now again there is an overflow here, because the maximum capacity for a non-root node is also 4, right? So but here we have 5. So same thing has to be done. You take the middle element and take it to the top. Okay, okay, so we take it to the top. So here we again earlier we had 30 here, but since here we have an overflow, we have sent it up. So at the upper level we are having how many keys now? We have 2. We have 15 that has come from the earlier one, and then we have 30. But now here you can see that we have more than one key value here. Okay, so as it was said that if you have 2 keys, then you must have 2 plus 1 children. Yes, earlier you had 1 key, so you had 1 plus 1 children, which was 2. So this is 1 and this is 2. But now you have 2 keys with you, so the number of children will be 3, right? So now you can see the number of children are 3, because this 6 and 7 will come to the left hand side of 15, as you can see here, and this 18 and 25 will come in between 15 and 30. Why? Because if you go from the left side to the right hand side, everything should be in the increasing order. So 6, 7, then 15, then 18, 25, then 30, then 36, 42, 46, 40, 44, 46. So as we go from the left to right, you can see that they are all beautifully arranged in the ascending order. Okay, so that's why now again the condition is also satisfied, that if you have 2 keys, then you should have 3 children. So we have 3 children here. We have 1, then 2, and then we have 3. Okay, is it fine? So everything is going smooth up to this point. Then after 6, what we are doing, we're adding 37, I think. Okay, where were we? Okay, we were here, right? Then we have added 37, so 37 has been added here. Then we add 70. So okay, even before adding 70, when you made it 37 here, you have already crossed the limit, because for a particular non-root node you can have maximum 4 nodes, but here 4 keys, but here we have 5 keys. So again same treatment has to be done. The middle element will be taken and taken to the upper level, and then what happens here is we have 15, 30 and 42. Okay, so now just a correction, whenever you say upper level, here we are saying upper level only to give you the suggestion that we go to the higher level, you can say, but in reality the levels are in the downward fashion. But anyways, let's not try to confuse that. Here just remember that here I mean that this 42 will be shifted to the upper shelf. Okay, so here we have 15, 30 and 42 here, and then now we have how many keys with us? We have 3 key values with us, right? So that means the number of children will be 3 plus 1, which is 4, and see we have 4 nodes here, 1, 2, 3 and 4. So this is totally fine. Okay, because see we have 6, 7 should come to the left hand side of 15, 18, 25 should come in between 15 and 30, then 36 36 and 37 should come between 40 and 30 and 42, and 44 and 46 should come after 42. So everything is fine. Okay, so then we again keep on adding elements. So let us try to add more elements. 70 has been added. No, so 70. Okay, so 70 has been added here. Then we have 11 has been added here. Then we have 99 is added here. Then we have 55, so 55 is added here. So once we reach 55, we see that we have this particular structure where again the capacity has been exceeded, right? So we should have 4 elements, but after we have put elements up to 55, we see that there is a overflow and 55 has to go up. Okay, so now as 55 has gone up, here we have 15, 30, 42 and 55. Okay, so that is it fine? So let us try to verify it once, because this is a root node, right? So can we have maximum of 4 elements? Yes, we can have maximum of 4 elements for root node also. So this is totally fine up to this point. Okay, so in the root node we have 4 elements, 4 keys here, that is fine. And then when we put 55 up, we have also splitted these values of 44 and 46 and 70 and 49. Okay, so they are also split so that everything remains in a order. So 6, 7, 11, 15, 18, 25, 30, they all go in the ascending order from left hand side to the right hand side. Okay, and now we add another element, 48 and 50. So here you can see 48 and 50 are added. So this is fine because now we have 4 elements in this particular node, that is acceptable. We can have up to 4 elements. So let us again see what is the next element we have. So after 48 we have 50. So okay, so yes, so once, oh no, 50 is also possible, so we are still at this particular stage. So then we add 52. So after what was the value, 50, after the value 50 we have added 52. So here you can see we had 50 and then we have added 52. So ultimately this particular node has exceeded the maximum value, right? The maximum value that we can have is 4, but we have 5 here. So what we have to do, the same thing. Okay, we have to take the middle element, take it to the top. Okay, and then we have how many elements here now? We have 15, or sorry, how many keys? We have 15, 30, 42, 48 and 55, and we have splitted 44 and 46 and 50 and 52 between this 48 value. Okay, so now everything looks fine, right? Like we have 6, 7, 11, 15, 18, 25, 30, 36, 37, 40, 42, 44, 46, everything is in the ascending order. Everything looks fine here, but the only problem that we have is that the root node can have maximum of 4 elements, but now we have 5 elements. So what do we do? Simple. Okay, you just take the middle element and then create a new level, okay, or make it the new root node. So what happens here is 42 goes up and becomes a single root node, and then you split all the elements that were in the left hand side to the left hand side and all the elements to the right hand side to the right hand side. So since 42 has gone up, we have 15 and 30 in the left hand side and 48 and 55 in the right hand side, and all other elements will look same because they are attached with 15 and 30. So if you look 6, 7, 11, we have 6, 7, 11, then we have 18, 25, 18, 25, 36, 37, 36, 37. So everything is fine because we have kept 50 and 30 together, so these elements will also be attached to 15 and 30. Similarly, in case of 48 and 55, we can see 48 and 55, we have 46, 46, 44, 46, 44, 46, 52, 50, 52, 50, 52, 70, 99, 70, 99. So you can see that they are also attached and there is no need of changing their places. Okay, so now it is fine. We have the root node of 42, then we have the next level of 15 and 30 and 48 and 55, then we have the next level which consists of all the leaf nodes as 6, 7, 11 up to 70, 99. See, if we consider this collection of elements as a node, how many nodes do we have? We have 1 node, 2 node, 3 node, 4 node, 5, 6, 7, 8, 9 nodes with us. Okay, and how many leaves are there? We have 1, 2, 3, 4, 5, 6. They are all nodes, right? They may have multiple key values, but they are in the end nodes. Okay, so you can see that all the leaf nodes, they all fall in the same level. Okay, so this is how we have been successfully able to create this B tree. Please remember this, please try to practice this. Whatever I have shown you, first just look at the explanation and try to understand it and grasp it, then you try to do it on your own. So you take a piece of paper and try to replicate this entire process without looking at it. Okay, if you're able to do it and you get the same output, then it will pretty mean that you have got the concept and we can move forward. So with that, I would like to wind up here. We are going to meet again in the next video. Thank you.